Hello everyone, I'm Abhishek and today I have Nikhil Simha from Airbnb on our latest episode of True ML Talks. I'm really excited to have him here. He's an industry practitioner with over 9 years of work experience in the analytics, AI, and ML space. Nikhil brings a wealth of experience in building sophisticated ML systems. He has previously worked with me actually in Facebook, and he has worked in Walmart and Amazon also. Currently, he's working as a staff software engineer at Airbnb. At Airbnb, he's part of the machine learning infrastructure team, building a distributed aggregation system for real-time feature generation. He was also an integral part of the team that built Zipline, which is Airbnb's data management platform for machine learning. Would now love to invite Nikhil to add anything else I have missed in your introduction.
No, that's comprehensive. Thanks for
Awesome.
having me here.
Awesome. Really excited to have you, Nikhil. So let's get started. So basically, Nikhil, let's start with tell us something about the data science and machine learning team, like at Airbnb. How big is the team? What are some of the exciting projects you're working on?
Yeah, the team is north of 300 folks, 300 data scientists, but people in different designations. Like there's machine learning engineers, besides data scientists, there's data engineers who also do a little bit of machine learning sometimes. And then there is software engineers who also do some sort of machine learning. So there's a lot of machine learning usage at Airbnb. Almost every surface that you see is in some way powered by a model, like be it search, talking to the chatbot when you call the customer support agent. Like every surface that you see is more or less generated or curated by machine learning.
Interesting. I'm curious, like with the incoming, like with the new advent of LLMs, like the domains that you mentioned, like search and customer support, especially, they are going through a huge change.
Yeah, yeah.
Any like is the same thing happening inside Airbnb? Are you looking at like OpenAI or like using some of the open source models?
A lot of this is still under discussion. We
Okay,
haven't decided one way or another, or like committed to a decision yet. But yeah, the world for CS in particular is going to change. The customer support is very heavily impacted by LLMs in a positive way. Like you can do things you couldn't do before and more or less trust the model to do it right consistently and explain why it did something.
nice, awesome. Would love to hear, Nikhil, a little bit about the ML stack that you have,
Hmm.
starting from like training of the model, then deploying the model. How do you monitor the model? Let's start with the training side of things, like
Yeah,
how is the data stack organized and how do you conduct training today?
I'll start maybe from user to backend. So user has access to this environment called Redspot. We have talked about this externally. So if you Google Redspot and Airbnb, you'll find some information. So Redspot is a notebooking environment where you can choose different kinds of base images and different kinds of machine types, and it starts up a notebook for you. And these notebooks or the containers are managed by Kubernetes.
Understand.
So their users like author their model, and finally they create a model object, which is the trained version of the model. So this notebook also has access to this other thing called BigQ. BigQ is our training cluster. You can submit jobs there, track the progress of your training. You can track the evaluation results of your previous runs. You can conduct hyperparameter search. You can choose between distributed or single node training. You can choose again machine types and whatnot. So that behind the scenes integrates with different kinds of frameworks, but for distributed training, it's primarily Horoward, Uber's Horoward. We
Okay,
did some benchmarking before we picked Horoward, but Horoward seems to be the most performant or like the thing that scales most horizontally.
I see. Okay, interesting. Actually, for our users like who are not familiar with Zipline, I think Nikhil, it's time that you introduce Zipline. What is Zipline and what is
Uh,
the motivation behind it? What does it do?
yeah, so I'll do a 2 minute pitch. There
Mhm.
is data in your company in many different forms. There is data in Hive, there is data as events in somewhere probably in Kafka, then there is data also in services which are backed by live databases or MySQL instances or what have you. Now, when a user says, I want to check if looking at the last year's booking average booking price of a user is indicative and helpful for showing him next search results. Right? You have an idea, and the data for this average transaction price exists in the transaction stream or in the transaction database or in Hive somewhere, right?
Right.
And depending on which point in history you want to look at, or how recently you want to look at it, or if you want to go through the database or not, you would look at either the stream or the database or the Hive table. So to create training data sets, you almost always have to look at Hive,
Right.
right? And to create the most recent average, you cannot usually look at the database because you're going to run a range scan on the database, and people don't like that when you run range scans on their databases. So you have to create a index on your own that listens to the database changes and updates this average whenever there is a change.
Hmm.
And not only that, you cannot wait for a year to finish building this index because you're looking at 1 year's worth of average transactions, right? You would need to
Yeah.
bootstrap that using data in Hive. So hopefully I motivated the problem. Just to summarize again, you take that one idea, which is average transaction price of a user in the year, and to build that in an index, it's a ton of work and ton of like figuring out where the data is, how to plumb it all together, how to maintain the index in real time, how to create training data sets, and how to ensure that the quality of the data that's being served is good. So
Hmm.
Zipline is the system that automates all of this at Airbnb. So
Okay.
it provides powerful windowed aggregations. It allows you to express SQL fragments that are Spark SQL valid, use UDFs and whatever to transform your data. But eventually, it's like creating training data sets and the serving endpoints. So those are the two outputs and some dashboards which show you data quality. Those are the three like main outputs. But behind the scenes, we create all the data pipelines necessary.
I see. That's quite fascinating, actually. Actually, Nikhil, like, would love to understand a little bit more about the red spot and the big queue that you mentioned.
Mhm.
Do you host these notebooks? I'm guessing as containers. Like, do you use like Jupyter Hub, or these are like individual Jupyter Lab notebooks that you have?
It's currently based on Jupyter Hub. Jupyter Hub, a little bit on Polynote for Scala stuff.
Okay,
Mostly Jupyter Hub connected to Kubernetes to launch containers. And we customize that heavily to like create different flavors of notebook kernels.
I see. Okay. Yeah, because that's why I was asking, because the native flavor of Jupyter Hub that comes, like, that has a lot of. We also tried using Jupyter Hub, but then uh, like persistence of dependencies. Like once you install, the pod will keep coming, going up and down.
Yeah.
Uh, and then if you need different sort of resources, or if you want to shut down the notebooks after some period of inactivity, that is the same for everyone. Things like that. I was wondering, like, if you face similar problems.
Yeah, so we customize this setup very heavily. We only use Jupyter Hub sort of to give us the UI of the notebook, more or less.
I
Everything else is customized. We have our own pruning jobs. We have our own integration with Elastic Block Storage to
Hmm.
persist users' work beyond the existence of the Kubernetes pod. So
Okay.
we can like keep their data around. And by default, we have like a 14-day policy. So if your container is inactive for more than 14 days, we kill the pod basically. But your EBS data is still like stored somewhere.
Okay. And you allow people to spin up notebooks on GPUs and things
Yeah,
like that. Uh,
yeah.
which cloud provider do you use?
AWS.
AWS fully. Okay.
Currently on AWS for most of our workloads. There is one or two elsewhere, but mostly AWS.
I see. Okay. And the big queue you mentioned is powered by Horoward, like it's running on Kubernetes only.
Yeah, it's also Kubernetes, Horoward, and our own customization on top. Yeah.
I see. So what does the abstraction look like? Like, is it more like the data scientist just writes a function, or you have different abstraction for hyperparameter tuning? If I want to run a training script, do I just submit it to the queue and it gets picked up and executed? Uh,
So it's a bit more flexible in the sense that our very lowest level abstraction is do distributed training or distributed runs or do a single machine training. Right now,
hmm,
if you think about hyperparameter optimization, it is just a version of distributed training. You're just like doing something sequentially, but you're doing different runs on different machines,
right.
searching through different hyperparameters for efficiency. All right. So it's a Python method simply that uses the base abstraction and we expose that to the user.
Interesting. And big queue is actually is it like a queue that jobs get submitted to and then they're picked up?
Yeah, it's essentially that. It basically, if the cluster is busy, then your job is waiting in the queue. That's what we make the abstraction seem like to the user.
Okay, interesting. Uh, and then, like, once they submit the job, the model is trained. Then, uh, I'm guessing there must be some model registry where the models get saved to, or the artifacts or things like that. How is that organized?
That is S3, like good old blob store that takes the model artifacts, stores them in a folder somewhere, and there is a registry which contains the link to that S3 artifact.
I
And the
see.
registry is like some sort of a OLTP store where, like MySQL or whatever, which contains different attributes, and the link to this S3 is one of the attributes.
Understood. So, is this more like do the data scientists choose themselves which S3 bucket it will go to, or like it's all abstracted away from them?
It's all abstracted away. Yeah.
Okay,
They
so they
still have control over S3, but it is mostly for like reading input data and storing. If they have any output data, they'll store that. But the this part of model management is abstracted away.
Interesting. And then what happens, like, let's say the model goes to the registry and then you want to deploy the model either as a batch inference job or as an API endpoint. So what is the process for that?
So we have two other systems. One is called ML Automator. It's mostly a library. Like if you're a user, it's called Batch Inference Library. And there
Hmm.
is another one which is Deep Thought. So when you deploy to Deep Thought is our online inference library.
Okay.
You like give it a bit more parameters on like what is the maximum number of pods you can assign or what is the minimum number of pods, what's the scaling policy. You have control over all of that. But basically, we take all of this Python looking configuration and like convert that into Kubernetes stuff and create Kubernetes clusters or Kubernetes pod groups.
I see. And
And
then, yeah, go ahead.
And for the offline thing, like whenever inference is requested, we just download that. We behind the scenes again use BigQ abstraction, right? The same
Okay.
thing. We just download the model from S3 and push data into different nodes and get batch inference results and put it back out into S3.
Understood. Okay. For the real time inference, I think you mentioned deep thought is the no ML automator is for the real time inference, right?
ML Automator is the batch inference,
Is a
and
batch
Deep
inference.
Thought is the real-time inference. But
Okay.
the names are a bit, not very aligned to what they do, but we can we can just talk in terms of batch inference or online inference.
Okay. So for the real-time inference, like, do you have these problems that data scientists will probably decide the CPU and memory that is needed by them, and sometimes it goes out of memory. So where do they get to see these failures, the logs, the metrics of what the model is doing? Uh,
So we use Datadog for all of this.
okay.
In the company, that's the standard. Everything at Airbnb is based on Datadog. So we emit a lot of metrics onto Datadog, and we also integrate with the existing alerting system, which is PagerDuty, and that's all programmatic. So you can programmatically generate dashboards, programmatically generate alerts and stuff. So our alerting policy is kind of uh, traditional. to in some sense. So initially, you give us a few numbers. You tell us what is the read QPS,
Hmm.
and based on that, we estimate how many pods you would need.
How do
And
you estimate that? Like how many requests per second a model will be able to do?
we store this when you do the test run, when you do model eval, right? We can tell what the throughput of a single pod or single core.
Oh, interesting. Actually, okay.
So we know roughly what the throughput can be, and we discount that because batch inference is going to be anyways faster than point inference.
Yes.
So we do some discounting. It's an approximate formula, but it works
Hmm.
decently well. And once we have that number of what's a QPS, we calculate how many pods you would roughly need, and we have a percentage. We suggest basically. We say, you can set this lower bound, set this upper bound, and we start from there. And when there is an issue, like when the utilization goes above 80%, the users and our system gets an alert. It's not automatically remediated, but we say then you can like scale up if you
I
need to.
see. Interesting. Uh, and so once the model is deployed, you mentioned alerting and all, and then I'm guessing the monitoring data, like, does every inference and prediction like tuple go automatically to some store, or do you have to
Yeah.
set up monitoring? How does that work? Do you
So
sample?
yeah, it's a great question. We log the inferences, features, and everything. Like the query comes in saying like, give me user features for search, right?
Hmm.
So we pull user features from like our Zipline thing, and
Hmm.
then send that to the model, get a prediction out, and we log this entire list like of user ID, timestamp, the features, and the prediction into one data set offline for every model.
So there is two questions here that I have, Nikhil. One
Mhm.
is when you're deploying the model, you have to write the code that will get the features from the Zipline store and then put it in the model, right? So is this code
It,
written by the
it's
data
a link.
scientist?
So it's not really code as such, it's a link. So in your configuration of your model, like
Hmm.
how you say how many pods or whatever, but in the very early configuration, you say this is the zipline uh, dataset name that I'm going to use. And that name is used both for offline training and also for online serving.
Interesting. So does that mean every model has a Zipline dataset?
So Zipline is mostly for structured data, right? So if you have unstructured data, you probably like refer to the dataset directly. Instead of saying this is a Zipline dataset, you say this is a S3 dataset or a Hive dataset if you don't want any computation. So yeah, we have flavors of what kinds of dataset a model can use,
Hmm.
and Zipline is one of the flavors. Also happens to be the most commonly used one.
Okay. But in the real-time inference, Nikhil, like when you want to get these features, like let's say from this data set and all, uh, you'll probably want them at a very low latency, right? So,
Yeah.
and the question is like, I guess my first question is like, are the data scientists writing that predict method in which they call this data set, get the values, pass it to the model, load the model, and then do it?
So they are not writing that. We already have the association between which zipline dataset and which model, that
Okay.
association already exists. So when we say, given this user, give me the, or given this user and listing, give me
Hmm.
the probability with which, user will book this listing, right? So we directly do that. Behind the scenes, we know which zipline dataset to query. We query that. We have a
I
low
see.
latency endpoint that Zipline creates to query that.
Hmm.
And they pass it into we directly pass it into the model and get the prediction and pass the prediction out.
I see. Okay. Nikhil, so want to understand, like, let's say you mentioned that people don't like doing this range scan queries on the database. So
Mhm.
probably you're putting listeners on data using like the transaction logs and DBZM or something like that. Is that what you do?
Yeah, so there is different kinds of
Or
logs. There is
you-
click logs, view logs, whatever. Those things don't go through database, but some things do go through database, like bookings. They go through database. So we have to listen to, depending on what user wants. We either listen to like regular streams, or like we internally we have a system called SpinalTab, but it is very similar to Debezium.
Okay.
So listen to either Debezium based change logs or like regular events and
I
build the index.
And these things, I'm guessing, they eventually end up in Kafka as different
Yeah.
topics, basically.
Yeah.
Uh, and then let's say the example that you gave, like the average transaction value of a user in a year. Let's say I
Mhm.
was to get this value. So then probably I can get historical data by running a Hive query, right?
Yeah.
Uh, so for that, I will have to probably write this map reduce job or maybe do it over Spark. Uh,
So in Zipline, you don't have to write those. You define the this compute once, which says this is the table and this is the topic and
okay.
this is a transformation I need. So do some, normalization of like currency to dollars or whatever, and then
Hmm.
say average dollar value of the transaction. So it's a aggregation which is windowed, average 90-day on that column. So Zipline has a DSL that allows you to express that, and we take that and we produce the offline Spark pipelines and also the online pipelines that update the index in real time.
I see. And these online pipelines, are they like pretty much like Kafka consumers that you're doing? Something like, I don't know, what are you using there?
It uses Spark streaming
Okay,
and some Spark jobs. It's a Lambda architecture behind the scenes, basically.
I see.
Batch
Okay,
correction happening every day. We have to batch correct because of change data. Some aggregations you cannot account for, like max. You cannot delete a max, right?
right. Yeah,
So you have to batch correct for those aggregations. So those are like non-group aggregations, and these the ones that can allow deletion are group aggregations. So basically, we distinguish that, and we tell users if you're using non-group, they get corrected at the end of the day. That's what we also do offline. So offline, we generate the same kind of features using the mutation logs.
I see. Understood. Uh, and these, I'm guessing, so sometimes, so does that mean that the payload of the data in the topic, like in the Kafka, is exactly similar to Hive, or because let's say the aggregation table in Hive is different, and you're getting the aggregation from two topics in Kafka, and you have an ETL pipeline after that that's then writing it to Hive. So uh, how do you correlate that thing, that you have to listen to two topics in one case, or is never the case like that?
So far, I mean, this again goes back to the convention at Airbnb. For us, it is one topic mapping to one table always.
Okay,
Right. So unless we haven't seen that break, we have been working with a few other companies, but that is usually how things are set up. There's always one topic backing a table. So we just have that standardization.
understood. And what do you basically, you mentioned that this Spark streaming jobs and you update the index. What do you use? And I guess your the low latency endpoints are basically just hitting this index and getting back the data. Are you using, like, what do you use to store this index?
Currently, we have, so RocksDB, right?
Yes.
RocksDB, so HBase has its own RocksDB called H region,
Okay.
right? So we use the H region and we distribute it ourselves using Apache Helix and Zookeeper, and we
Okay.
call it muscle. So there's probably some material about it externally as well, but it is that H region plus Zookeeper plus Apache Helix, that itself is a distributed database for us. We don't manage that. We have another team that manages it for us. So we work with them to set up the indexes programmatically.
I see. Okay. Will something like Redis also work in this case?
Yeah,
Or
anything will work. So all we need is bulk update and regular put, regular get, and scan by time. So I need events ahead of this time watermark. Internally, we use that to like stitch together data, but that time thing or like range scan is all HBase, Cassandra, RocksDB, all of them have range scans.
I see. Understood. Will KSQL too similar, at least on the Spark streaming side of things, like keeping the index and keeping the value?
No, index is something we have to maintain ourselves, and we have to write our own
Hmm.
client that does the post aggregation logic, right?
Okay.
But KSQL could work, but the issue is user writes. We are trying to take this computation definition and generate Spark pipelines and streaming pipelines, right?
Right.
And the streaming pipelines need to also understand the same SQL more or less, or the same DSL.
Hmm.
So that rules out a lot of incompatible stuff. Like Spark SQL, for example, supports structs natively. It supports inline lambdas natively. It supports UDFs, any Hive UDFs natively. We want to have the same property in the streaming job, right?
Okay.
We are more or less like logged into using Spark streaming for that, for these
Understood.
three reasons.
Understood. So just for understanding of our viewers, Nikhil, basically, uh, whenever a user says that I need a feature, like as you mentioned, like the average transaction value of a user, the user will, the data scientist will submit your DSL, and behind the hood, you'll generate a Spark streaming job and a Spark job that collects the data.
Yeah.
Uh, and then you probably, for the real time access, you store it in the index, the muscle thing that you mentioned, and then for like batch ones, like they are stored in another Hive table which people can just query. Is that what it is? It's just putting the
Yeah.
data.
So in the batch one, so when people define in our DSL, they also can compute labels. Like for search case, it's the conversion, right? And
Yes.
for customer support, like the agent basically says this ticket is of this type and it's been resolved. And for similarly for everything, it's these are all like again Hive tables that are that are used to compute labels. So for offline, we also use that label definition and create the entire training set.
Okay.
And that itself again is a Hive table, which the systems ahead of it, like BigQ and whatnot, they pick up these Hive tables and convert those into models or retrain models again.
Okay. Understood. And this, as let's say, this feature that the data scientist submitted a DSL for, does
Mhm.
it become like a feature in your feature store that they can access in any other model? Uh,
Yeah, they can. Yeah. So we have a group by and a join. And a group by represents all the features that are computed from a single source. And a join represents a collection of features from different sources or different group bys. And for us, the unit of reuse is the group. So all features coming from a single source get reused by reusing the group by. And different joins or different models can use different group bys. So if you have, say, transaction features, right? And search model is using that, customer support model also can use that, fraud model also can use that. But
hmm.
it's the same index behind the scenes.
Okay. Wow. That's quite interesting. And I'm guessing you then use this same system to power your ML monitoring also.
Yeah, actually we do. That's an interesting question, but yeah, we do. We basically compute uh, data quality or like feature quality and prediction quality as Zipline group bys. It's the same engine like behind the scenes that computes these metrics.
Hmm. And what were the like, Nikhil, some of the challenges? I'm guessing, like, how long have you been working on Zipline? What were the interesting challenges that you had to overcome?
Yeah.
Uh,
So I'll start by saying this. We have been working on this for 5 years and we have rewritten this thing twice.
okay, like
And
every.
for every time we had to rewrite it for larger scale and for handling more skew or more data skew. So, and most recently, the rewrite was driven by handling like 100x larger scale and like 100x larger throughput in the online system. And the aim is to have 10x lower latency for stuff like search. So when I say 100x, what I mean is like hundreds of billions of rows that need to, or like the output training set could be hundreds of billions of rows.
Hmm.
And when I say 10x lower latency, I mean before it used to be 100 milliseconds P95. Now we are like at 10 milliseconds P95. So there's a lot of re-architecting that went into that. A lot of algorithmic work, Spark optimization, a lot of index optimization that went into all of that. Yeah. In terms of lessons, I mean, one thing we thought really helped is if the framework really understood data models, like how you have fact and dim, and events and databases, and slowly changing dimensions. If the database is aware of these things, we can optimize heavily based on the data models. And it's also less work for users to tell us how to handle different data types by themselves. That I think really helped. And the rest of it is like good old, algorithmic optimization and optimizing Java function code, that kind of stuff.
Interesting. Like, is there a is Zipline like one part of the whole ML platform team? Like, how big is the ML platform team roughly at Airbnb?
We are half of the ML platform. It's maybe a little bit more than half. But we have two sides. One is the data side, which is Zipline, and then
Hmm.
there is model side, which is the rest of it. If you
Okay.
think about this in terms of pipelines that you need to generate, there will be probably like 20 plus up to 80 data pipelines that power features. And there is one pipeline that like trains the model, right? The amount of work is skewed towards data side for a data scientist. And that's
Hmm.
the reason why like this is slightly more than half of the ML platform.
Nice. Yeah, that makes sense. And like, what are the some of the new things coming up? How have you seen things ML evolve over the years? You've been working on it at a long time. So, is
Yeah,
there a change in the way people are working now? The set of requirements.
yeah. I mean, it has always been changing. Like, if I remember correctly, I joined Airbnb in 2017 and left Facebook same time. And every model at Facebook at that time was an embedding model, or using embeddings in some way. There's very few models that did not use embeddings, and rest of the industry is on that path right now. There is going to be more embedding models and more powerful embedding models. And the advantage of embedding models, quite frankly, is that you don't need to have a lot of label data if you have sequences of activities or sequences of text or whatever,
Right.
right? And they give meaning. Like, let's say you are a user who logs from India, books typically in like Europe or US or whatever, then there is really no labels here. There's just activity sequences, right? And that represents your identity in some way. You don't really need a label to have this information in the model that you're from India. And whenever like you try to log in from Thailand, we can say, okay, this looks kind of like fraud, so maybe we should ask for more verification. And until this point, like there isn't a lot of like labels going on, right? There's just activity sequences. And there's also even subtler things like how fast you type and how fast you click on the website. All of those things, they don't have labels. But you can still generate embeddings that capture that signal without doing supervised training.
Right.
And that's why I think embeddings are so powerful. And we are just seeing that, more of that now at Airbnb, where we're using embeddings in almost every flow.
I see. Interesting. Once you, I guess, do you actually do like monitoring when you have like embeddings and things like that? Like those start becoming a bit more convoluted, right?
Yeah, that's right. That's a very good question. So the current state of the art way of monitoring embeddings is through this thing called UMAP. It clusters embeddings in like a spatial set somewhere, and if there is an anomaly, so it's basically something's out of cluster happening more frequently, and you can alert by saying your embedding distribution has shifted.
Right.
So then we also alert based on distributions of the raw features themselves that create the embeddings.
Hmm.
We also say, maybe these correlate to the shift in embeddings. I mean, we don't say that. We create like correlations or shifts for every features individually. And
Hmm.
today, at least, our users like uh, work through these shifts themselves. And they say, okay, this upstream data source has changed. And they go and try to fix it or retrain the model.
Hmm. Makes sense. Uh, Nikhil, what would you recommend like for let's say mid-size companies for their MLOps stack? Like how much should they invest? Should they buy? Should they build? Which part should they build? Like what would you advise someone like who is starting to build models and facing the same set of problems that you have faced?
My recommendation is, I mean, I'm biased, right? I work on the data side of things, but I also objectively think it is harder because there's a lot more pipelining to do. Like there is 100 features and one prediction, right? So,
Right.
and everything is a library now. Like if you're using XGBoost, you're configuring the model basically, or
Yeah.
if you're using some kind of spacey, or if you nowadays it's not even that, right? You're just plumbing data into open source models, that large models that are trained on some existing corpus and getting data out of it. So more and more the focus will be on the data side. So my recommendation is to have really good conventions in your warehouse, because no one can fix that. Like there is no unified data platform which stores events and tables and picks a format and like allows you to query both of them together. There is no vendor that does that. Snowflake or Databricks does it only for offline stuff. And for online, like you use Confluent, and even there you don't know what's the format. So the best recommendation is tools will be coming up, like something like Zipline and all. We're looking into open sourcing it. That will happen. There will be more tools. If not Zipline, there is Feather, there is Feast, Hopsworks, whatever. So to use those tools, you need to have like a really good conventions around your data. It's number one. And
Hmm.
everything else is mostly plug and play. You can like buy if you are understaffed, and if you don't want to build any of this yourselves or maintain the open source stuff yourselves, you can buy. But if your data warehouse is bad, there's you cannot use that data anymore. It will be very hard to create, these kinds of systems that require real-time data. Like personalization, fraud detection, customer support, they all need real-time data. Like, without them, you cannot identify intent, essentially.
That makes a ton of sense. Uh, Actually, when is Zipline getting open source? Nikhil, I think I talked to you like a year
Yeah.
back.
So it's been a journey, but we are like kind of closing up. We are partnering with two other companies in the valley. I cannot share who, but two other companies in the valley, kind of well known for their ML infra work in the industry, right? So our exit strategy from that into open source is that they have deployed it in production for themselves, and then we will flip the switch.
Okay, I didn't understand. Like they have deployed Zipline also in production, like the same.
Yeah, that's our criteria. They need to have served production traffic through Zipline.
Okay, understood. And then they will also help, like open the open
Yeah,
sourcing process.
yeah. I
Understood.
mean, they're already contributing back, and
Okay, right.
improved this thing tremendously already. So.
Okay, that's great actually. So that is great, Nikhil. Wanted to understand like till Zipline gets open sourced, like
Mhm,
let's say a company is getting data in Kafka, has some data in Hive.
mhm.
What would you suggest as the stack? Like just build something like Zipline, or is there anything out there that can substitute or even come close to building the stack, or do you have to build it in house? Can they get something in a 1 or 2 days running? Like the same example that you gave, what is the thing that a company will do without having Zipline?
Yeah. So right now it's like months of infrastructure work, and but there is this project from LinkedIn called Feather, which is currently open source, but it's closely aligned to Azure ecosystem. So if you're
Mhm.
not on Azure, like it might be hard to use. But I would look into that. But otherwise, if you have a structure to the warehouse, it makes the job of building it in-house also easy.
Okay,
And all these tools rely on that structure. Like you cannot use any of these things without having a convention on, okay, my Kafka data is going to be in thrift format or protobuf format or like JSON or whatever. Like you need to stick with it, and then also have like a one-to-one mapping between Kafka topic and the Hive table, and like make sure it's like populated regularly and does not take a lot of time to land the Hive table and whatnot. Like getting that is a foundation of everything, right? Like whether you do analytics or machine learning or any other thing, that's the foundation that has to be solid.
makes sense. And what are like anything on the Gen AI LLM? Like, have you been tracking it?
Yeah,
Putting-
we have been tracking it fairly well. I mean, we are starting efforts on building like foundational infrastructure for Gen AI stuff. So, like the ability to use open source models, fine tune them, and do RLHF through like labeling companies like Labelbox or whatever,
Hmm.
right? We almost have like a infrastructure setup ready for those things. We have like a couple of use cases going through them right now, going into prod. So right now it's all greenfield, it's nascent. The LLM infra space is kind of nascent, but I think it'll get there, it will mature soonish. And especially CS is going to see a huge impact from this LLM stuff. Any customer support work that your company needs to do will probably go through LLMs in the future.
Makes sense. That makes a ton of sense. Anything else on your mind, Nikhil, that you would like to add?
Mm, nothing technically, but I really appreciate that you guys have me here.